The cosmos is immense, yet the portion you and I can perceive is merely a tiny sliver. This audio course is an invitation to journey to the very edge of the observable universe, the most distant frontier our scientific instruments can probe. The question of what exists past this boundary tests the limits of not just our telescopes, but our entire conception of reality.
The importance of this subject is difficult to overstate. In an era of unprecedented scientific advancement, comprehending our observable horizon helps you situate yourself within the cosmos and gives context to everything in existence. It is from this cosmic shoreline that we can start to unravel the universe's deepest mysteries, from its origins to the formation of galaxies and the fundamental nature of matter and energy. Defining the observable horizon is much like attempting to describe an epic theatrical production when you can only see one corner of the stage. This horizon represents the greatest distance from which light could have possibly traveled to reach us since the universe began. In this sense, it serves as a unique portal into our cosmic history, a looking glass that reflects the earliest light from the dawn of creation.
So how is this immense distance actually calculated?
When discussing the observable horizon, you enter a domain of sophisticated measurements and intricate mathematics. Because light moves at a finite and constant speed, when you observe celestial objects, you are fundamentally peering into the past. Every star and distant galaxy you see appears not as it is now, but as it was millions or even billions of years ago.
The expansion of the universe itself is a central character in this story.
Picture a balloon being inflated. Any 2 points drawn on its surface will move away from each other as it grows. In much the same way, the fabric of the universe is stretching, and as it does, our observable horizon expands along with it. This paradoxically means that as the cosmos ages, ever more of it slips permanently beyond our capacity to see.
The constant speed of light imposes another fundamental constraint on our powers of observation. While it might seem that an infinite sea of stars surrounds us, what we can actually detect is a very limited fraction of all that exists. Since light from the most remote objects requires billions of years to complete its journey to us, the images you perceive are not only from a faraway place, but also from a long-vanished time.
As we explore the observable horizon, it is vital to differentiate between the cosmos we can perceive and the universe that lies just beyond our view. An entire, potentially infinite expanse exists that we cannot currently detect. This raises tantalizing questions about what might lie past this boundary. Perhaps entire other worlds or different realities are waiting there to be found.
One fascinating phenomenon tied to the universe's expansion is the Doppler effect, which manifests as redshift for light. This principle explains how light from distant objects shifts toward the redder end of the spectrum as they recede from us, much like how the pitch of a siren deepens as it moves away. This effect doesn't just confirm that the universe is expanding. It also gives you crucial insights into how this expansion relates to our observable horizon. Dark matter and dark energy introduce two more layers of complexity that shape the universe's structure and expansion. Although these components are invisible to us, their gravitational effects are unmistakable. Much like a jigsaw puzzle with crucial pieces missing, our cosmic model remains incomplete without accounting for these unseen elements, which may be the very forces binding galaxies together against the tide of expansion. The lambda CDM model, currently our standard cosmological theory, offers a comprehensive framework for understanding how these fundamental forces work. This model posits that the universe is composed of ordinary matter, dark matter, and dark energy, giving us a foundation to study the limits of our observable horizon. By exploring this model, you can begin to ask profound questions about the ultimate structure and destiny of the cosmos.
The most distant galaxies, shimmering at the edge of our observable limit, act like celestial lighthouses in the cosmic darkness. They provide a direct glimpse into the universe's evolution across billions of years, telling ancient stories and hiding profound secrets. These galaxies compel you to consider your own place in the cosmos and the deep connection you share with the universe's ancient past. Our technology for observation has been a critical partner in the quest to map the observable horizon. Advanced telescopes and other scientific instruments have dramatically extended our reach, enabling us to peer deeper into space than we ever thought possible. With each technological leap, our comprehension of the cosmos grows, relentlessly pushing the boundaries of what you and I are able to see. The notion of a multiverse introduces yet another dimension to this exploration. Consider the possibility that our universe is merely one among a countless number of others, all coexisting within a far grander cosmic tapestry. This idea, while speculative, forces you to reconsider what the observable horizon truly signifies in such a vast context. Is it possible that parallel realities exist that we will never be able to witness? Finally, the cosmic microwave background radiation, also known as the CMB, is the faint afterglow of the Big Bang, an echo of the primordial universe. This remnant radiation gives us invaluable clues about the conditions in the universe's earliest moments, prompting you to contemplate the limits of observation and how data from the distant past can inform our understanding of the future. Within this ocean of ancient light, countless discoveries are still waiting for you to find them. The idea of the observable horizon is as perplexing as it is captivating. But have you ever paused to consider what it genuinely signifies? To grasp it, you might envision an immense ocean, where each wave symbolizes a distinct moment in time. Far out in this ocean lies a shoreline you cannot perceive, and this unseen coast is what we refer to as the observable horizon, the very boundary that dictates the extent of our cosmic view. The reason this limitation exists is rooted in the fundamental properties of light and time. The observable horizon represents the furthest distance from which light could have possibly traveled to reach us since the universe first came into being. This distance is determined by the speed of light, a constant velocity of approximately 300,000 kilometers per second, which, despite being incredibly fast, is finite in a universe that is still relatively young from an astronomical standpoint. Since the Big Bang occurred roughly 13.8 billion years ago, there has only been a specific amount of time for light to travel, meaning we can only perceive a fraction of all that exists. Consider a lighthouse standing on a distant shore. If your boat is close enough, its beam can serve as a guide. However, as you drift further away, that light will weaken until it vanishes entirely. In the same way, some regions of the universe are so remote that the light they emitted long ago has still not completed its journey to us. Consequently, the observable horizon is not a static barrier, but a dynamic one, constantly expanding as the universe itself ages and grows. With each passing moment, light from previously unseen stars and galaxies finally arrives at our telescopes, continually unveiling a cosmos in a state of perpetual transformation. This implies that while our view is limited today, the future promises a much more expansive cosmic vista. Nevertheless, not everything in existence is contained within this ever-widening sphere of observation. There are cosmic territories that remain entirely beyond our capacity to see, which presents some truly fascinating questions. What could possibly exist beyond this boundary that we are destined never to cross? Is it possible there are galaxies hosting life forms that will forever remain unknown to us? This profound mystery
prompts us to recognize that while science has made incredible strides, a vast amount of knowledge still lies beyond our grasp. The observable horizon, therefore, is more than just a physical constraint. It carries significant philosophical weight. It forces you to contemplate your own place in this immense cosmos, and what it means for our understanding of life if the universe is indeed infinite. The questions it raises about whether we are truly alone, or if other life exists beyond our reach, are truly thought-provoking. The expansion of the universe might feel like an abstract notion, but it's crucial for understanding our perception of the world. Our universe's history, as we currently understand it, started billions of years ago with the colossal event we call the Big Bang. To visualize this, think of a balloon being slowly inflated. Points drawn on its surface start close together, but are driven apart as the balloon gets bigger, which serves as a helpful analogy for how galaxies are receding from one another as spacetime itself expands. This is where Einstein's theory of gravity and general relativity give us the framework to probe the very fabric of spacetime. By analyzing how massive objects like black holes warp their surroundings, we can start to piece together the universe's intricate structure. This investigation reveals how cosmic forces not only shape the cosmos, but also influence our perception of it and guide the future of our explorations into space. The possibility of life existing beyond our observable horizon challenges the very definition of existence. It forces us to ask whether we are a solitary phenomenon in this vast expanse, or if there is other life waiting to be found in realms we can never access. These questions drive us to meditate on the significance of our own lives and the part we play within this grand cosmic story. Ultimately, investigating the observable horizon does more than just deepen our comprehension of the universe. It encourages a profound reflection on our connection to it. As we push further into this field of study, we find ourselves on the brink of unveiling new truths about the cosmos and our specific place within it. Each time you gaze up at the night sky, it's worth remembering that you're peering through a veil, a boundary that links us to the past while simultaneously pointing the way toward the future. Hello. If this journey through the universe sparks your curiosity, and you wish to continue exploring the mysteries of the cosmos, I invite you to subscribe and activate notifications. Today, we are going to delve into one of cosmology's most captivating and complex subjects: the speed of light. This concept is not only fundamental to how you perceive the universe, but it also stands as one of the primary constraints on our observable horizon. The constant speed of light is approximately 300,000 kilometers per second. While that figure is staggering, it poses a distinct challenge when observing the cosmos. Have you ever stopped to think about why certain parts of the universe are simply impossible for you to see? The core of the answer is directly linked to this finite speed. To understand this, imagine you are in a boundless cosmic ocean where light moves through space like waves. Every single wave that reaches you carries an image from a moment in the past. As a result, the more distant the wave's origin, the older the image it delivers to you. This principle means that whenever you gaze at the night sky, you are effectively peering through a portal into the universe's history. For instance, the light from Proxima Centauri, the star closest to our solar system, requires more than 4 years to reach Earth. This means you are seeing the star not as it is now, but as it appeared over 4 years ago. And for galaxies much farther away, this time delay can extend to millions or even billions of years. This inherent delay is what defines the observable horizon, the greatest distance from which light has had sufficient time to travel to us since the Big Bang. The ongoing expansion of the universe directly impacts this boundary,
continuously shaping the limit of what we are capable of detecting with our instruments. It is important for you to recognize that the universe is not a static environment. It is a dynamic and ever-changing stage. Not all galaxies are receding from us at an identical speed, as the force of gravity affects their motion. This leads to a fascinating and complex question. What occurs when a galaxy moves away from us at a velocity that surpasses the speed of light? The Big Bang Theory offers a framework not only for how the universe began, but also for how it continues to evolve. In the first fractions of a second after its birth, the universe was an incredibly hot and dense cauldron of particles, packed so tightly that light could not escape. It was only as the universe expanded and cooled that light was finally able to travel freely, giving you a glimpse into the earliest chapters of cosmic history. So, what would you see if you possessed a telescope so powerful it could look beyond our observable horizon? The answer is truly captivating. You would most likely witness galaxies that we can never hope to reach or even know exist. This idea generates profound questions about what lies beyond our perception. Are there simply more galaxies, or perhaps even other universes entirely? As galaxies travel away from us, the expansion of space itself causes the light they emit to stretch, shifting it toward the red end of the spectrum in a phenomenon called redshift. This effect does more than just tell us the speed at which galaxies are receding. It also offers crucial insights into the history of the universe's expansion. The fact that the universe is expanding not only challenges your perception of distance, but also forces a re-evaluation of your core ideas about time and space. Modern theories suggest that the cosmos may be far more immense than we can comprehend, containing regions we will never be aware of due to the speed of light and this perpetual expansion. A fascinating aspect of this expansion is its connection to dark matter and dark energy. These enigmatic forces are believed to influence the grand structure of the cosmos and are considered the primary drivers of its acceleration. While you cannot see them directly, their existence is inferred from the ways galaxies cluster together and move through space. As we explore these concepts, we inevitably arrive at the ultimate question: what does the future hold for the universe? Will the expansion persist indefinitely, or might there come a point when gravity overcomes it and reverses the process? These inquiries are not merely scientific. They carry deep philosophical weight, compelling you to reflect on your place in the cosmos and the fundamental nature of reality itself. The expansion of the universe represents an incredible journey, inviting you to explore not just what you can see, but also what may lie forever beyond our observational reach. It's a challenge to contemplate the sheer vastness of the cosmos and the wonders potentially hidden in the depths of space. Therefore, as you look up at the starry sky, let it serve as a reminder that every star and galaxy is a piece of an unfolding cosmic history. Human curiosity, driven by scientific inquiry, pushes us to seek answers, even when those answers only lead to more profound questions. This journey of discovery has only just begun. An intriguing question naturally emerges. What is it that prevents us from seeing beyond this cosmic boundary? The explanation is rooted in the expansion of the universe itself. Ever since the Big Bang, the fabric of space has been stretching, causing galaxies to move away from us. Because the speed of light is finite, any light from galaxies receding faster than that speed can simply never bridge the distance to reach you. This cosmic expansion means that the more distant a galaxy is, the more rapidly it recedes from our vantage point, and therefore, the more challenging it becomes for its light to ever arrive here. Picture an inflating balloon with points drawn on its surface. As the balloon gets bigger, the points spread farther apart. If you were on one of those points, you would observe all the others moving away. The universe behaves in a similar fashion, which means the light from the most remote galaxies simply hasn't had enough time to reach us before they were carried too far away.
This situation brings up a captivating thought. Is there an absolute, unchangeable limit to what we can ever observe? The answer is yes, but this boundary is not static. As the cosmos continues its relentless expansion, our observable horizon also transforms. Some galaxies that are currently beyond our perception may one day drift into view, while others that you can see today might eventually disappear forever. A striking reminder of just how dynamic our universe is. The speed of light introduces another fascinating concept, the dimension of time. When we state that we are observing a star that is 1,000,000 light-years away, we aren't just referring to a physical separation, but also to a temporal one. You are, in effect, gazing into a past that would otherwise be entirely inaccessible to you. But what if it were possible to overcome the light speed barrier? In theory, we might be able to witness the universe in its earliest moments, though this idea directly challenges the laws of physics as we currently know them. So, what does this reveal about the fundamental nature of the universe? It reminds us that there are inherent limitations built into our perception. Even though we have engineered advanced technologies to peer beyond our immediate horizon, there will always exist a boundary that you cannot cross. This reality compels us to consider our own place within this vast cosmos. We are like explorers on a sea of light, where each arriving wave delivers a story from the distant past, but where some shadows will always remain beyond our reach. In the end, the speed of light not only dictates how you perceive the universe, but also establishes the very frontiers of our understanding. It serves as an invitation to question what we think we know and to embrace the reality that, regardless of our accomplishments, there will always be more to uncover. The next time you look up at the night sky, consider the tales the stars are trying to tell you, and how the light you see is just a tiny fraction of what truly exists. Have you ever wondered how many stars exist in the universe? Astronomers suggest that the cosmos contains more stars than all the grains of sand on every beach on Earth. Still, what we can perceive is only a tiny portion of what is actually out there. This is where we encounter the difference between the observable horizon and the entire universe. The observable horizon is like an immense mirror, reflecting only what is visible to us within the cosmos. To understand this, imagine you are standing on an endless plain, gazing toward the horizon. Everything you perceive is the ocean, yet you are aware that much more lies beyond the limits of your sight. The observable horizon is similar. It reveals only a segment of the cosmos, while an entire universe extends past what you can detect. The observable part is a sphere with a diameter of roughly 93 billion light-years, a scale that is nearly impossible to truly grasp. In contrast, the entire universe might be vastly larger, perhaps even infinite. The key to understanding this distinction lies in the universe's expansion. Since the event known as the Big Bang, the cosmos has been continuously stretching. This expansion doesn't just push galaxies away from one another. It also defines the very edge of our observable horizon. As the universe grows, light from the most distant objects requires a longer time to get to us, meaning we can only see those whose light has had enough time to complete the journey. This process raises a profound question. Just how many galaxies are forever lost beyond our cosmic horizon? The speed of light is a central character in this story. Even though light travels at an incredible velocity, it cannot cross the immense expanse of space in an instant. Therefore, every time you look at the sky, you are actually looking into the past. For instance, observing the star 10 light-years away means you are seeing it as it was 10 years ago,
placing a fundamental limit on our ability to see the universe in real time.
Even if our horizon expands as light from more distant objects finally reaches us, you will never be able to know everything that exists in the universe. This is because there are regions so incredibly far away that their light will never reach us, ensuring these areas remain forever in the shadows. Furthermore, the universe is not only a place of marvels but also of deep mysteries. Dark matter and dark energy are two components that constitute most of the cosmos, but remain largely invisible. While you cannot see them directly, their impact on the structure of the universe is undeniable, prompting us to wonder what other secrets are concealed in the parts of the universe we cannot observe. Cosmology. The scientific discipline that investigates the origin and evolution of the universe has profoundly shaped this entire narrative of exploration and discovery. The natural curiosity and desire to explore that are part of our human character are precisely the impulses that drive us to seek out the unknown universe. So when you next look up, remember that the light you see is just a small piece of a much grander, more mysterious reality that is waiting to be understood. The standard model of cosmology, known as lambda CDM, provides a framework for comprehending the behavior of the entire universe. However, this very model concedes the existence of boundaries to our knowledge. Many theoretical frameworks propose that the cosmos extends far beyond what we can perceive, which raises the profound question of how you could ever confirm what exists past your cosmic horizon. For astronomers, remote galaxies hold a special fascination, with some being so distant that their light has journeyed for billions of years just to arrive at our planet. By examining these ancient light sources, you gain insights into the very formation and evolutionary path of the universe, allowing them to reveal secrets about both the cosmic past and its ultimate destiny. Technology has been absolutely essential in our search for cosmic answers. Advanced telescopes and sophisticated instruments have dramatically broadened our understanding and extended the limits of the observable horizon. With every technological leap, fresh questions emerge about what further discoveries could be unlocked with even more powerful tools, making you wonder if we can ever truly surpass our current observational limits. The concept of a multiverse introduces a thrilling dimension to this entire conversation. Consider the possibility that our universe is merely one among countless others, each possessing its own distinct observable boundary. Such a notion would fundamentally alter your perception of reality itself, yet it simultaneously presents far more questions than it resolves. Ultimately, contemplating what lies beyond our cosmic viewpoint compels you to confront the nature of your own existence. It makes you ask, what is our role in this immense cosmos? And what does it truly signify to be human within a universe that might be endless and filled with mystery? This pursuit of understanding can be just as enthralling as the cosmos it seeks to explain. The observable horizon challenges you not just to investigate what is visible, but to envision what remains unseen. In this grand quest for knowledge, where each discovery often unveils deeper enigmas, the journey itself feels as boundless as the universe. Have you ever considered the mechanics of the universe's motion? The answer is deeply connected to two critical phenomena that are key to grasping our cosmic position: the Doppler effect and redshift. Let's begin with the Doppler effect, a concept you encounter in everyday life. Picture yourself standing by a road as an ambulance approaches with its siren on. The pitch seems to rise as it nears you, and then fall as it passes. This apparent shift in sound frequency is the Doppler effect. Remarkably, this same principle applies to light, where an object's light waves will shift toward blue if it's moving closer to you, and toward red if it's receding.
So, you might ask why this is significant for our understanding of the cosmos. Across the vastness of space, astronomers have consistently observed that nearly all galaxies are traveling away from our own. This means that the light we receive from them is shifted toward the red end of the spectrum, a phenomenon called redshift, which serves as the unmistakable signature of an expanding universe. A helpful analogy is to visualize a balloon being filled with air. As it inflates, any dots drawn on its surface will spread further apart from one another. In much the same way, galaxies are receding from each other, providing us with vital clues about the universe's history. This concept of an expanding cosmos was a revolutionary break from the long-held belief that the universe was static. And it was the analysis of redshift that revealed a grand narrative of expansion, stretching back to the Big Bang. This cosmic expansion has profound implications for how you perceive the observable horizon. Because the universe is constantly growing, the light from the most remote galaxies requires billions of years to complete its journey to us. Consequently, when you look at the night sky, you are not seeing the cosmos as it is today, but are instead peering through a window into its distant past, making every star and galaxy a kind of celestial time capsule. But what about the galaxies that are receding so quickly that their light is destined never to reach us? These celestial bodies exist beyond our observable horizon. To grasp this, imagine you are navigating a vast ocean where each wave symbolizes a galaxy. You can interact with the nearby waves and see those further off. But some waves are moving away so fast, they will eventually vanish from view. This is precisely the situation with a vast number of galaxies in our expanding universe. Redshift reveals something even more profound about the nature of space and time. It shows that the farther away a galaxy is, the more rapidly it recedes from us, which indicates that the universe's expansion is actually accelerating. This puzzling acceleration led scientists to propose the existence of dark energy, a mysterious force thought to be fueling this cosmic growth. Within this magnificent and enigmatic cosmos, the Doppler effect and redshift are more than just abstract scientific ideas. They represent the essential keys that allow you to unlock the universe's greatest secrets. The relationship between these phenomena and cosmic expansion provides a captivating glimpse into the workings of the universe, revealing that we are part of a perpetual journey of discovery, where every answer prompts new, even deeper questions about the wonders waiting in the depths of space. With every technological leap, our telescopes grow more potent, enabling us to intercept signals from progressively more remote galaxies. Ultimately, the Doppler effect and the phenomenon of redshift are the very instruments that allow us to interpret the universe's language. These tools reveal that the cosmos is in a perpetual state of transformation, and although some answers still elude us, each new discovery draws us nearer to grasping our place in this immense and enigmatic reality. So, when you next find yourself gazing at the night sky, remember that you are not just seeing points of light. You are witnessing the chronicles of an expanding cosmos, narratives from a universe that consistently inspires awe and beckons us to venture beyond the visible frontier. Science hands us the keys to unlock these cosmic puzzles, and with every solution we find, a new set of questions emerges. Just what secrets might the universe share with us the next time we turn our eyes to the stars? Among the most compelling and perplexing ideas in modern cosmology are dark matter and dark energy. But what are they, precisely? And what makes them so vital to comprehending the observable horizon? To understand, picture yourself in a completely dark room. You can't see a thing. Yet you can feel the presence of other objects around you, perhaps by the sounds they make. This sensation is a very close parallel to how we perceive dark matter and dark energy throughout the cosmos.
Dark matter is akin to an unseen shadow whose existence we infer from its powerful effects on visible matter. For instance, when we study a galaxy, we can measure the movement of its stars. If we were to calculate the necessary gravity based only on the matter we can see, it wouldn't be nearly enough to hold those stars in their orbits. This is where dark matter enters the picture. Though it remains invisible to us, its gravitational influence is undeniable and helps explain how galaxies form and navigate the vast cosmic sea. Dark energy, however, presents an even more fascinating puzzle. Think about blowing up a balloon. As you force more air in, it expands. Dark energy appears to be the force inflating the entire universe, causing its expansion to accelerate. This is truly remarkable because, while we have known the universe is expanding since the Big Bang, dark energy is the reason this expansion is speeding up. The exact nature of this energy remains one of science's most exciting mysteries.
These two components, dark matter and dark energy, are absolutely essential for making sense of the observable horizon. Without them, our picture of how the universe operates would be critically incomplete. Dark matter provides an invisible scaffolding that underpins the structures of the universe, while dark energy is the driver of its expansion. Together, they give us a far more expansive view of cosmic reality and compel us to ask, could there be much more than we are able to see?
The significance of dark matter and dark energy is not merely academic. Imagine trying to create a map of the universe. If you were to omit dark matter, your map would be fundamentally flawed and fail to represent the cosmos accurately. Likewise, without factoring in dark energy, you could never explain why the universe's expansion is accelerating. Both of these elements are required to construct an authentic depiction of the cosmic landscape.
The question then becomes, how can we be sure they exist if we can't see them? The answer lies in the elegance of scientific deduction. By observing the motion of galaxies and their gravitational interactions, researchers can infer the presence of far more mass than is visible, much like seeing ripples on a lake without spotting the fish beneath. And as for dark energy, the key to its discovery lies in observing supernovae, which are the brilliant explosions of massive stars. By analyzing the light from these events, astronomers realize they are more distant than they should be, suggesting some unknown force is pushing galaxies apart. As we explore these ideas more deeply, a critical question comes to mind. How do dark matter and dark energy relate to our observable horizon? The answer is that this horizon isn't just a physical limit, but also a boundary of our current knowledge. With every new insight into these mysterious forces, our entire understanding of the universe could shift. The observable horizon is like a great veil drawn across the cosmos. It reveals what we can see while simultaneously sparking our curiosity about what lies beyond it. When you pause to think about it, it is incredible how these concepts can alter our perception of reality. They aren't just scientific curiosities. They serve as powerful reminders that the universe is teeming with surprises and that there is always more to find. Pondering these invisible forces leads to an exhilarating question. What other wonders does the cosmos hold for us? This relentless search for answers propels us forward, reminding us that the observable horizon is merely the starting line for our grand exploration. As we journey onward through space and time, dark matter and dark energy will continue to be the beacons that guide us into the unknown. Within the expansive discipline of cosmology, one of the most central theories is the lambda-CDM model, which has risen to become the standard framework for comprehending the universe and its development over time. Not only does this model allow us to understand the expansion of the universe since the Big Bang, but it also offers a vital framework for interpreting the observable horizon. So, what precisely is this framework, and why is it so crucial to our conception of what exists beyond the limits of our vision? The lambda CDM model, in which lambda signifies dark energy and CDM denotes cold dark matter, serves as a kind of cosmic roadmap, charting the entire history of our universe and providing a detailed picture of how all matter and energy are distributed throughout space.
This cosmic map brings the notion of the observable horizon into sharp focus. You can imagine this horizon as a conceptual bubble that surrounds us, defining the boundary of what we can perceive within the immense expanse of the cosmos. A central tenet of the lambda CDM model is that the universe isn't just expanding. Its expansion is actually accelerating. This is much like blowing up a balloon, where points drawn on its surface move away from each other at an ever-increasing rate as it inflates. In our universe, it is the galaxies that act as these points, and they are receding from one another more and more rapidly. This cosmic expansion has a direct and profound effect on our observable horizon. Galaxies that were once within our observational reach are now moving away so fast that they are destined to cross this boundary, disappearing from our view forever. This raises a fascinating question. Does this accelerating expansion imply that there are sections of the universe we can simply never observe? The answer to that is an unequivocal yes. Certain galaxies are already so distant and are retreating at such incredible speeds that their light will never manage to reach us, regardless of how many billions of years we might wait. This reality forces us to contemplate the very nature of the observable horizon and its deep connection to the passage of time and the speed of light. The mysterious force behind this acceleration is dark energy, a component believed to constitute about 70% of the universe's total contents. To visualize the effect of dark energy, think of a vast ocean where every galaxy is a wave. Dark energy behaves like a persistent wind that pushes these waves farther apart, causing them to separate at an accelerating pace. In spite of its overwhelming influence on the cosmos, we still have a very poor understanding of what dark energy truly is. This lack of knowledge underscores the value of the lambda CDM model, as it gives us a structured way to investigate dark energy and its ultimate impact on our cosmic horizon. Using this model, we can project how the universe is likely to evolve in the distant future. For instance, what will be the ultimate outcome as our observable horizon continues to shift? Some theories propose a future where the universe becomes an exceedingly cold and dark void, as the galaxies you can see today gradually recede beyond our sight. The other critical component in this cosmic equation is dark matter. Though it is completely invisible to us, we can detect its presence through the powerful gravitational influence it exerts on galaxies and their movements. Much like unseen icebergs in a dark ocean, dark matter accounts for the vast majority of the universe's mass. Its gravitational interaction with the visible matter you see is fundamental to explaining the large-scale structure of the cosmos, making its inclusion in the lambda CDM model absolutely essential. This leads us to wonder about the galaxies that reside beyond our observable horizon. Even though we will never see them, their existence stands as a powerful testament to the sheer scale of the universe, reminding us that it is far grander than we can possibly imagine. Every time you gaze up at the night sky, you are faced with the humbling truth that there is so much more out there than your eyes can ever perceive. As science continues to advance, we slowly unravel these cosmic mysteries, and the lambda CDM model is a formidable instrument in this exploration. It compels us to question our very perception of reality. If what we can see is limited by this horizon, what does that suggest about our overall comprehension of the universe? It's possible that there are physical laws yet to be found,
or hidden dimensions that remain inaccessible to our senses. Cosmological research is a field of constant change, with each new finding bringing us a step closer to understanding our place in this vast cosmos. Confronted by this immensity, it would be easy to feel overwhelmed, but the Lambda CDM model provides a sense of direction. It offers a framework to arrange our theories and observations, giving us a glimpse of a future where a full understanding of the universe might shift from an impossible dream to an attainable reality. The quest for knowledge is a journey without end, where each answer we uncover only generates new questions in an infinite cycle of discovery. Ultimately, the Lambda CDM model is far more than a theoretical construct. It is a gateway to the unknown, inviting you to explore, to question, and to stand in awe of the universe's majesty. As we push our exploration forward, the observable horizon becomes less of a limit and more of a symbol of our own curiosity and deep-seated desire to know what lies beyond. To grasp this, imagine you are standing on a beach looking out at the ocean. You know the water continues far beyond what you can see, but your vision ends at that distant line. In the same way, the cosmic horizon marks the greatest distance from which light has had time to reach us since the Big Bang, a boundary we relentlessly seek to understand. It is theorized, in fact, that the cosmos may harbor an extraordinary quantity of galaxies, a great number of which are so remote that their emitted light has not yet had sufficient time to traverse the distance to us. This presents a fascinating puzzle. If we have never seen these galaxies, how can we be certain they exist? The solution is found in the way scientists interpret the data available to them. They employ theoretical frameworks and observations of more proximate galaxies to project what might exist in the regions beyond our sight, which is much like possessing an unfinished map of a land. While you lack every detail, you can logically deduce that more territory awaits discovery. Distant galaxies are essential for helping us piece together the universe's origin story and its subsequent evolution through time. You can think of every galaxy as a volume in a cosmic library, each one chronicling the history of the universe, but many of these chronicles are concealed from our view. Imagine every galaxy as a single point of light against a black canvas. The more of these lights you can perceive, the more clearly the surrounding picture comes into focus. Yet, a vast number of these lights are still shrouded in darkness, awaiting the moment of their detection. Astronomers have managed to identify some of these faraway galaxies with the help of powerful telescopes, capable of gathering light from objects across immense cosmic distances. But what of the ones we haven't found yet? How is it possible to investigate something that cannot be directly observed? One remarkable method for tackling this problem involves studying the cosmic microwave background, which is the residual radiation from the universe's inception. This ancient echo provides vital clues about the fundamental structure of the cosmos and its ongoing expansion. Through careful analysis of this relic radiation, scientists can begin to grasp not only what lies past our observable horizon, but also the processes that led to the formation of the very first galaxies. In essence, studying this glow gives us a look at a far more expansive universe than our eyes and instruments can directly see. Simultaneously, by examining galaxies in our own cosmic vicinity, researchers can deduce general principles about their formation and life cycles, which contributes to a more thorough portrait of the cosmos, even with certain sections remaining out of our direct reach. These remote galaxies frequently present a different appearance compared to the ones we see in our own cosmic neighborhood. Some appear young and brilliantly active, teeming with star formation, whereas others might be much fainter, having already passed through a lengthy aging process. This naturally leads you to ask what these distant celestial bodies can reveal about our own position within the grand scheme of the universe. The observable universe is truly immense, and the edge of what we can see is merely the starting line for our exploration, with each new finding drawing us nearer to comprehending the cosmos's true character and our role within it. Another captivating concept is the inherent link between distance and time throughout the universe. When you observe a galaxy that is billions of light years from us, what you are actually witnessing is that galaxy as it appeared billions of years in the past. It is analogous to viewing an old photograph of a friend. The picture captures that individual at an entirely different stage of their life. In this way, faraway galaxies serve as portals to the past, enabling us to journey backward through cosmic history. Still, a great deal of uncertainty persists. Current theories on cosmic evolution propose that galaxies existing beyond our field of view might possess characteristics dramatically different from those we are able to analyze. This possibility unleashes a vast spectrum of creative speculation. Is it possible that galaxies with forms and hues we've never conceived of exist? What sorts of chemical processes might unfold in such remote environments? Science, therefore, is not only a discipline of finding answers, but also one of generating new questions that push the limits of our comprehension. When you reflect on these distant galaxies, it is crucial to appreciate the part technology plays in our exploration of space. Telescopes have undergone astonishing advancements, and every fresh discovery edges us closer to a true understanding of the universe. There is, however, a fundamental boundary to our perception, which is defined by the observable horizon. As our technology forges ahead, our capacity for discovering new galaxies will undoubtedly increase, yet there will likely always be areas of the universe that stay concealed from us. The search for galaxies beyond what we can see also carries profound philosophical weight. If the universe is indeed without end, what does that imply about our own existence? It compels you to contemplate the significance of our place in such an immeasurably vast cosmos. The chance that there are innumerable other galaxies, some of which could potentially harbor life, forces us to consider our own solitude and our connection to a greater cosmic community. Are we truly alone? Or could we be a part of a much larger cosmic society? Ultimately, as you contemplate these remote galaxies and everything they signify, it is vital to recognize that science is an ongoing expedition. Every single discovery gives rise to new inquiries and deeper mysteries. The galaxies that reside beyond our capacity to observe serve as a constant reminder that, despite our remarkable progress, an immense amount of territory remains unexplored. The quest for knowledge is a perpetual one, and each galaxy we manage to uncover represents one more piece in the grand puzzle of the universe. On this cosmic voyage, every one of us is an explorer, pushing to make sense of the unknown and to see what is waiting just beyond our horizon. Have you ever felt constrained by your available tools, much like a painter with a single brush who is unable to capture the full scope of their creative vision? Astronomers encounter a very similar predicament. As we delve into the boundless universe, we are confronted with the reality that our observational powers are limited. But this does not imply they are unchanging. In fact, the progression of our technology has been nothing short of extraordinary, empowering us to see past frontiers that were once considered impassable. The saga of astronomical observation stretches back to ancient civilizations, when people first gazed at the night sky and pondered the nature of the stars. Across the centuries, these profound questions fueled the invention of ever more powerful instruments, from Galileo's pioneering telescopes to the colossal observatories of today. Each technological leap has served to revolutionize our grasp of the cosmos. fundamentally reshaping our perspective by functioning as increasingly powerful extensions of our own senses. This endeavor is not merely about peering deeper into space. It's about seeing things that exist outside the current limits of our understanding. Picture yourself standing in a pitch-black room, holding just a single candle that illuminates a tiny circle around you. Now, flick on a powerful floodlight, and suddenly the true, vast scale of the room is revealed. Telescopes function in much the same way, casting a brilliant light on the cosmos and allowing us to gather light from objects that were previously beyond our sight, unveiling new marvels. It's important to remember, however, that the light we observe from these distant sources is not from the present moment. When you gaze upon far-off galaxies, you are quite literally looking back in time, as the light from them has spent millions or even billions of years on its journey to reach your eyes. It is as if we are opening letters sent from distant friends across both space and time. And we must ask, what tales do these ancient dispatches tell? And what secrets of the primeval universe do their luminous flashes disclose? Our story of cosmic exploration doesn't end with visual telescopes, which are certainly not the sole protagonists. Consider radio telescopes, for instance. These remarkable instruments let us listen to the universe instead of just looking at it. By capturing the radio waves that celestial objects emit, they not only broaden our observable frontier, but also grant us a completely different way of perceiving the cosmos. Can you fathom the idea of actually hearing the residual echoes from the Big Bang? Such is the wonder of our modern technology. As our scientific capabilities progress, our methods for observation evolve right alongside them. The field of astrophotography, for example, has utterly transformed our comprehension of the universe. Through the technique of long-exposure imaging, astronomers can produce pictures of celestial bodies so dim they are entirely invisible to the naked human eye. It feels as though the cosmos has concealed its greatest treasures within the dark, and we have just found the key to unlock them. What profound enigmas are brought to light in these vivid and colorful cosmic portraits? The age of space-based telescopes has elevated our quest to an entirely new plane of discovery. By positioning observatories high above Earth's obscuring atmosphere, we can circumvent the distortions that it causes. A prime example is the Hubble Space Telescope, which has delivered breathtaking images and facilitated breakthroughs that have fundamentally reshaped our view of the universe. What previously unsolvable mysteries has Hubble managed to unravel for us? The ongoing advancements in artificial intelligence are also revolutionizing the way we survey the cosmos. Sophisticated algorithms can sift through immense volumes of data with incredible speed, pinpointing patterns in celestial objects that human observers might easily overlook. So, could a piece of software actually discover a new galaxy before an astronomer does? The answer to that is an emphatic yes. Technology isn't just about expanding our vision, it's about deepening our understanding. Next-generation telescopes are being engineered to see across a broad spectrum of wavelengths, from the infrared to the ultraviolet. Each specific wavelength unveils distinct characteristics of celestial bodies. You can think of each of these spectral bands as a unique window that opens up onto a new dimension of the universe. What can we possibly learn by looking at the cosmos from all of these varied perspectives? Our cosmic exploration is not confined to passive observation from afar. We have also sent out robotic emissaries, like the Voyager probes, which have journeyed far beyond our observational horizon to send back priceless data about our solar system and the space beyond. Because of these probes, we have gained a vicarious experience of deep space, moving us ever closer to grasping our own place within the universe. If these robotic explorers could speak, what incredible stories would they share with us?
Telescopes are more than just instruments for scientists. They serve as conduits for our collective human curiosity. Every single image captured and every new discovery made compels us to formulate even more questions. They serve as a constant reminder that the universe is an immense and intricate puzzle, and each piece we manage to fit into place brings us that much nearer to the ultimate truth. What further questions will the cosmos present to us as we press forward in our search for knowledge? The future of astronomical observation is poised to be exceptionally thrilling. The next wave of powerful telescopes, including the James Webb Space Telescope, has been meticulously designed to challenge everything we think we know. What new frontiers will these instruments enable us to investigate? That answer is still waiting to be found. Yet, one thing remains absolutely clear. Our incredible journey is very far from complete. This technology of observation does more than just push back our visible horizons. It also fundamentally alters our perception of ourselves. The more we uncover about the universe and its staggering wonders, the more we comprehend just how small we are in the grand scheme of things. At the same time, this knowledge is deeply empowering, reminding us that every single discovery we make is a significant stride toward a more profound understanding of our own existence. In the end, observing the cosmos is an expedition that never fails to inspire awe. As our telescopes and related technologies continue to advance, our grasp of the universe expands in lockstep. The tools we create not only permit us to see beyond the visible spectrum, but also inspire us to dream, to question, and to continue exploring. Every captured image, every detected sound, and every piece of data is another portal to the unknown. And this grand adventure is truly just getting started. The concept of a multiverse may sound like it belongs in science fiction, yet it's an idea that a great number of scientists are exploring with genuine seriousness. Within the field of modern cosmology, the proposition of parallel universes brings up captivating questions concerning the very fabric of our reality. Could other universes exist alongside our own, each governed by its own unique physical laws and conditions? The potential answer to that question is not just compelling, it encourages us to completely reconsider what we understand the observable horizon to be. The observable horizon can be visualized as a bubble that envelops our known universe, and everything beyond this boundary remains a profound mystery. But what if our bubble isn't the only one in existence? Try to imagine a vast expanse filled with multiple bubbles, where each one represents an entirely separate universe. While some of these might be quite similar to ours, others could be fundamentally different, operating under principles of physics we can't even begin to conceive. This idea prompts us to ponder what it would mean if our choices, or even the realities we inhabit, played out differently in an alternate universe. The theory of the multiverse emerges from several different interpretations of quantum mechanics and cosmology. One of the most prominent is the many worlds interpretation, which posits that every decision you make causes reality to split into different universes. This suggests that in some other universe you seized that opportunity you let pass by, or maybe you followed a completely different life path. Not only is this concept fascinating, but it also provides a framework for comprehending the infinite possibilities that might truly exist. The idea of a multiverse is fundamentally connected to cosmic inflation, the theory that outlines the universe's explosive expansion in the moments following the Big Bang. According to this model, the inflationary process could have generated separate bubbles of spacetime, giving rise to distinct universes, each with its own unique properties. It's conceivable that some of these cosmic bubbles are so alien that life as you understand it would be impossible, which forces us to question our own place within the grander cosmos. Exploring the multiverse also requires you to grapple with its profound philosophical dimensions. If other universes truly exist, what does that imply about your own identity and purpose?
Certain philosophical perspectives propose that your existence is merely one among countless others, a notion that can feel simultaneously liberating and deeply unsettling. You are faced with the possibility that your life may not be as singular as you believe, even though every choice you make holds immense value within the context of your own reality.
This concept naturally brings up the question of whether you could ever establish contact with or journey to these alternate universes. Although modern physics offers no clear method for such travel, the fantasy of moving between realities has always captivated the human imagination. It's hard not to dream of visiting a universe where history unfolded differently, a world where dinosaurs still roam, or where humanity never ventured to the moon. As you delve deeper into this topic, it's crucial to think about how the multiverse would reshape your understanding of the observable horizon. The existence of other universes suggests that the cosmic boundary you can see is not the only one. Barriers like the universe's ongoing expansion and the finite speed of light prevent you from seeing beyond your own cosmic neighborhood. But what if these other realities are right beside you, existing in dimensions you have yet to learn to perceive? It's important to recognize that theories about the multiverse are more than just imaginative exercises. They are grounded in sophisticated mathematics and complex physical principles. While some scientists have developed models that describe how these universes might interact, the absence of direct empirical proof has sparked intense debate over the theory's legitimacy. This raises a fundamental question. Are you dealing with science or philosophy? The boundary is often indistinct, and that ambiguity is part of what makes scientific inquiry so beautiful. Ultimately, whenever you discuss parallel universes, you are also fundamentally questioning the nature of reality itself. If multiple realities exist, the problem of defining what is real becomes exponentially more complicated. Is your universe the one true reality, or are you merely a momentary flicker in an endless ocean of cosmic possibilities? Such questions compel you to think beyond your day-to-day experience and contemplate the vast implications of your cosmological theories. With the continued advancement of science, it is likely you will learn much more about the universe you inhabit and its potential connections to others. New technologies and theoretical frameworks may unlock doors that were once considered permanently shut, and perhaps one day, our telescopes and experiments will uncover the first real clues pointing to the existence of other universes. Just imagine the revolution that would spark in your understanding of life, existence, and your place in the cosmos. The multiverse also challenges you to reflect on the meaning of life from a much broader perspective. If there are infinite universes, each containing a version of yourself, what does that imply for the significance of your actions and decisions? These are questions that straddle both science and philosophy, and every potential answer only seems to lead to more profound inquiries. It reminds you that while your view of the cosmic horizon is limited, your capacity for curiosity and questioning is truly infinite, making the multiverse a powerful source of inspiration for your continued exploration of the cosmos. Now, let's explore the cosmic microwave background radiation and what makes it so captivating. To grasp its importance, you must travel back in time, roughly 13.8 billion years, to the period immediately after the Big Bang. In that initial moment, the entire universe was a hot, incredibly dense point, a kind of primordial soup so compressed that particles were packed too tightly for light to move through it. As the universe initiated its expansion, this elemental soup began to cool down, and eventually, it became transparent enough for light to be released. This event produced a faint, persistent echo that continues to permeate the cosmos to this day, which is what we call the cosmic microwave background, also known as the relic radiation.
In simple terms, when you gaze at the night sky, you are not just seeing stars and galaxies, but also this ancient light that has journeyed across billions of years to reach you, like a whisper from the distant past, revealing secrets of the universe's formation. So, how can you actually perceive this radiation if it is invisible to your own eyes? Scientists have engineered specific technologies capable of detecting it. Consider being in a completely dark room when you suddenly switch on a very small lamp. Even though the light is faint, it illuminates everything in its vicinity. In much the same way, telescopes designed to capture microwave frequencies can register this radiation, providing critical information about the universe in its infancy. What precisely does this ancient radiation tell you about the cosmos? The cosmic microwave background is remarkably uniform, appearing almost identical no matter which direction you look. This uniformity offers powerful evidence for the homogeneity of the early universe. You can think of it like a perfectly blended soup, where every single spoonful tastes the same. This consistency suggests that in its earliest stages, the universe was extraordinarily balanced and homogeneous, although, as you will see, it is not entirely without its imperfections.
While the cosmic microwave background is remarkably consistent across the sky, it possesses incredibly subtle temperature variations. You can think of these as faint ripples on the surface of an otherwise perfectly still cosmic ocean. These minute differences are of paramount importance, as they represent the primordial seeds from which all large-scale structures, including galaxies and their clusters, eventually grew. Without them, the cosmos would likely be a featureless void, devoid of the intricate and beautiful complexity you and I see today. By carefully analyzing this relic radiation, scientists have managed to determine the age of our universe with astonishing precision. It's akin to being able to reconstruct the entire story of a book by examining just a single, ancient page. The cosmic microwave background provides us with a direct snapshot of that inaugural moment, enabling a deep understanding of how everything has unfolded since. Through this research, we now know the universe is approximately 13.8 billion years old, a number that truly puts the vastness of cosmic time into perspective. Now, let's consider how this radiation affects the boundary of what we can perceive, known as the observable horizon. The cosmic microwave background essentially establishes a fundamental limit to our vision. Imagine yourself in the middle of a boundless ocean. Although the water extends endlessly, your view is confined to the horizon. In the same way, this ancient light delineates the farthest we can see into space, while also serving as our most profound window into the distant past. This naturally leads you to wonder what might exist beyond this cosmic curtain of light, and the answer is far from simple. While the cosmic microwave background gives us unparalleled information about the universe's infancy, whatever lies past our observable horizon is currently a complete mystery. It's possible that there are more galaxies, unimaginable cosmic structures, or even phenomena we have yet to conceive. The thought that there is more to reality than we can ever witness is both a thrilling and a humbling prospect. Furthermore, the cosmic microwave background is instrumental in helping us decipher the universe's fundamental composition. Through detailed analysis of its temperature patterns and distribution, scientists have been able to confirm the existence of dark matter and dark energy. These two mysterious components collectively constitute the vast majority of the universe's total mass and energy. Our knowledge of these crucial phenomena would be profoundly restricted without the data provided by this ancient radiation. And what about the deeper, more philosophical questions this all raises? The very existence of this persistent echo from the Big Bang forces you to confront profound inquiries about your own place within the cosmos. If the resonance of creation is still present today,
What does that imply about our own existence and our connection to that primeval event? Such thoughts can lead you to fundamentally re-examine your understanding of space, time, and the nature of reality itself.
Within the patterns of the cosmic microwave background, scientists have also discovered a wealth of data for testing theories of cosmic inflation, the theorized period of hyper-accelerated expansion in the universe's first moments. This phase is critical to explaining how the tiny quantum fluctuations in the early universe were stretched to astronomical sizes, eventually becoming the seeds for the massive structures we see today. Consequently, by decoding the layers of this relic light, we are effectively creating a map of our universe's entire history. Every new discovery brings us closer to answering the age-old questions that have always captivated humanity. Yet you have to ask if we can ever achieve a complete understanding of the cosmos. This question prompts a reflection on our own limitations as a species. The cosmic microwave background is more than just a physical phenomenon. It stands as a monument to our inherent drive to explore. It serves as a reminder that even though the universe appears incomprehensibly vast, each small piece of knowledge we gain is a significant step forward on an endless journey. Gravity is a force that is intimately familiar to all of us in our daily lives. But what if I were to tell you that its role in the universe is far more profound and enigmatic than you might imagine? When we consider the observable horizon, gravity doesn't just influence objects nearby. It fundamentally shapes our very perception of space and time. To grasp this, we turn to Albert Einstein's theory of general relativity, which provides an entirely new framework for understanding this elemental force. General relativity reveals that gravity isn't merely a force pulling objects toward one another, but rather a curvature in the very fabric of space-time. Picture a stretched trampoline and place a heavy bowling ball in its center. The ball creates a deep depression in the surface. If you then roll a marble nearby, it won't travel in a straight line but will follow the curve created by the ball. This analogy gives you a simplified yet powerful way to visualize how massive bodies, like stars and planets, literally bend the space-time around them. So, how does this concept connect to the observable horizon? When you think about this horizon, you are considering a boundary, a cosmic limit beyond which we cannot receive any light or information. This is not simply a static barrier in space. It is a dynamic boundary that is itself subject to the warping of space-time by gravity. As the universe continues to expand, distant regions are carried away from us so rapidly that the light they emit can never bridge the gap to reach us. Much like watching a door slowly close until your view is completely gone. This raises a fascinating question. Can gravity actually alter what we are able to see in the cosmos? The answer is an emphatic yes. Gravity has the power to bend the path of light from distant objects, functioning like a massive cosmic lens. This effect is known as gravitational lensing. It's similar to looking through a piece of warped glass, which can distort what you see, and even make a single object appear as multiple distinct images. In this way, gravity can amplify, distort, or even hide parts of the universe from our view. Finally, general relativity proposes that time itself is not absolute but is elastic, capable of being stretched by the presence of immense mass. For instance, close to a black hole, time would pass significantly more slowly than it does for an observer far away. This stretching of time, or time dilation, becomes an essential factor to consider when we contemplate the very edge of the observable horizon, as it fundamentally alters the nature of the information we receive from the most distant reaches of our universe. The light you attempt to study from extremely remote parts of the cosmos could have been sent on its journey millions of years ago. Because of gravity's influence in those distant areas, however, The image you receive today may not be an accurate representation of their present state. Furthermore, it is gravity that dictates how cosmic structures take shape and change over time, as gravitational attraction is the very force responsible for creating galaxies, clusters of galaxies, and other massive celestial formations. This leads to a compelling question. What impact does this have on your observable horizon? The galaxies nearest to you are held together by gravity, but the most faraway galaxies might be receding at such high speeds that you will never be able to see them. In essence, this suggests that the universe possesses a kind of boundary, determined not just by sheer distance, but also by the gravitational forces at play within it. On the subject of boundaries, it is captivating to consider black holes. These incredibly massive objects are formed from the collapse of a star and possess a gravitational pull so powerful that light itself cannot break free. This reality has profound implications for your observable horizon, as the presence of black holes demonstrates that some parts of the universe are fundamentally beyond the reach of your observation. Any light or data trying to exit a black hole is permanently captured, which establishes a definitive point of no return within the surrounding spacetime. Consequently, a black hole's event horizon serves as a potent analogy for the ultimate limits of what you can know and perceive. Yet, the outlook is not entirely grim, since general relativity also provides a sense of optimism and wonder when you contemplate the immensity of the cosmos. As researchers persist in their exploration, they continually unveil new secrets, revealing that gravity, rather than being merely a force of entrapment, is the essential link that connects and directs the entire evolution of the cosmos. Every new finding brings you nearer to comprehending the intricate nature of the universe and your own position within it. The drive of human curiosity is limitless, and for every answer you uncover regarding gravity and the observable horizon, even more questions emerge. This continuous cycle makes the quest for knowledge an unending adventure, always pushing you to ask what marvels exist beyond your present field of vision, and how you can leverage your understanding of gravity to probe the unknown. Ultimately, philosophy prompts you to contemplate the essence of infinity and your role within the cosmos. If your observable horizon represents just a minuscule portion of everything that is, what does that imply about your own existence? In its function as the force that molds the universe, gravity also serves as a potent reminder of just how restricted your comprehension truly is. At the same time, this limitation encourages you to persist in your exploration, to never stop asking questions, and to always imagine what might exist beyond what you can see. Science and philosophy can be seen as two facets of a single endeavor, each shedding light on different angles of your pursuit of understanding. Gravity and general relativity reveal that the observable horizon is more than a physical barrier. It is also a symbol of your deepest ambitions and aspirations. As you progress, the key question becomes not only what exists beyond your view, but also what breakthroughs await in the immense and enigmatic universe all around you. To truly comprehend the function of black holes in this universe you occupy, you first need to decipher what these cosmic puzzles actually signify. A black hole is a region in space where the force of gravity is so powerful that nothing, including light itself, can evade its grasp. This characteristic makes them both captivating and frequently disquieting objects in your perception of the cosmos, which naturally leads to the question of how they are formed in the first place. Black holes come into being when colossal stars use up all their nuclear fuel and subsequently collapse under the weight of their own gravity. Picture an enormous, blazing sphere that, once its energy is spent, crushes itself inward. This process of implosion generates such extreme density and gravitational force
that it results in the birth of a black hole. But what becomes of space and time in their vicinity? To answer this, you must turn to Einstein's theory of general relativity, which completely transformed your comprehension of the universe by describing space and time not as separate concepts, but as a unified fabric that bends when mass is present. Therefore, as a star implodes, it profoundly distorts the surrounding space-time, carving out a deep gravitational well from which no escape is possible. A black hole's event horizon constitutes the threshold beyond which you can no longer gather any information. Should you venture too near this boundary, gravity would seize you, making a return impossible. This reality poses an interesting query. Could there be objects or events happening past this horizon that you are destined never to see? Moreover, black holes affect the grand design of the universe, and if you envision the cosmos as an expansive ocean, these objects function like powerful vortices that can alter the cosmic currents and shape the movement of galaxies. As they devour matter, black holes can unleash immense quantities of energy as radiation, which subsequently impacts their local environment, prompting the compelling question of whether they might serve as the very engines of galactic evolution. The interplay between black holes and other cosmic bodies is even more profound, as demonstrated by the discovery of supermassive black holes at the hearts of numerous galaxies, including your own Milky Way. These giants, which are millions or even billions of times more massive than the Sun, can directly affect new star formation and the overall dynamics of their galactic homes. What part do these supermassive black holes play in forging the elements that constitute your planet, and, by extension, you? Now, let's explore the link between black holes and time, which behaves bizarrely near them. While time would appear to pass normally for a distant observer, it would decelerate for anyone getting closer to the event horizon. This strange effect prompts deep contemplation about the perception of time in locations where the laws of physics appear to fail, adding to the many fascinating paradoxes that black holes present. Among the most compelling cosmic puzzles is the information paradox. When a black hole devours information, does that information vanish from existence? A divide exists in the scientific community. Some theorists propose it can be retrieved, while others maintain its complete destruction, an idea that would defy the fundamental laws of physics. This very debate compels you to reconsider the fundamental fabric of reality. Our scientific inquiry doesn't end with the black holes we can currently observe. Theoretical models propose the existence of primordial black holes, entities that may have formed in the immediate aftermath of the Big Bang. These ancient objects could possess incredibly small masses and might still populate the cosmos, holding secrets about the universe's infancy. If they do exist, you have to wonder what cosmic truths they could possibly unlock for us. Contrary to their reputation for annihilation, black holes also serve as powerful engines of creation. When two of them merge, the collision unleashes a tremendous blast of energy as gravitational waves, which are essentially tremors in the fabric of space-time itself. These waves present you with an entirely new method for observing the cosmos, potentially holding the key to deciphering the universe's long and complex history. The reach of black holes may even touch upon the enigmas of dark matter and dark energy. Certain scientific hypotheses suggest they might be instrumental in helping us comprehend these baffling forces that constitute the vast majority of the universe. This raises a profound question for you. Could the components of the cosmos that remain invisible be just as crucial as those we can plainly see? Ultimately, the existence of black holes forces you to contemplate your own position within the grand scale of the universe. If such colossal and mystifying objects are possible, what other marvels might be waiting in the cosmos, just beyond our current reach of discovery? This pursuit of answers is an invitation for you to push past the known frontiers of our comprehension.
In essence, black holes are far more than mere astronomical events. They represent gateways to unexplored realms of both physics and philosophy. They compel you to rethink the nature of time, space, and information, guiding us toward the very edge of human knowledge. Contemplating their reality makes you appreciate that the universe is a place brimming with mystery, where every answer we uncover only leads to more profound questions, serving as a constant reminder that the quest for understanding is truly endless. The potential for life to flourish beyond our observable horizon is an idea that has captivated human thought for millennia. You can look at the night sky and imagine that each point of light might be a distant sun, orbited by its own family of planets. While most of these worlds are beyond your capacity to see, the mere possibility that they could support life forces you to reflect on your own place in the cosmos and ask if we are truly alone. To grasp this challenge, it helps to visualize the observable universe as an ever-expanding bubble with our planet at its center. Inside this bubble, you can perceive and analyze anything from which light has had sufficient time to travel to us since the dawn of the universe. Yet, outside this boundary, spacetime continues to stretch, likely containing innumerable worlds, some of which could be strikingly similar to Earth, though you can only speculate on what truly lies beyond your view. To grasp this challenge, it helps to visualize the observable universe as an ever-expanding bubble, with our planet at its center. Inside this bubble, you can perceive and analyze anything from which light has had sufficient time to travel to us since the dawn of the universe. Yet, outside this boundary, space-time continues to stretch, likely containing innumerable worlds, some of which could be strikingly similar to Earth, though you can only speculate on what truly lies beyond your view. The quest for extraterrestrial life has gained significant momentum in recent years, driven by remarkable technological progress. Sophisticated telescopes and ambitious space missions now allow scientists to identify exoplanets within habitable zones, which are orbits where conditions might permit liquid water to exist. But you must ask, is water the sole prerequisite? Life could perhaps manifest in environments starkly different from our own, with biochemistries based on silicon instead of carbon, or as organisms thriving in extreme conditions similar to those in Earth's deepest oceans. Of course, the immense distances and the limits of our observable horizon prevent you from confirming any of these theories. If advanced civilizations do exist, gazing at the same cosmic tapestry, how could you ever know? The renowned Drake equation provides a framework for estimating the number of technologically advanced societies in our galaxy, but every variable within it is shrouded in uncertainty. This exercise remains purely speculative, yet the sheer possibility it presents is nothing short of breathtaking. The discovery of life elsewhere would have profound consequences, revolutionizing not just your understanding of biology and evolution, but potentially reshaping our entire philosophy and spiritual outlook. If you were to learn we are not alone, it would force a re-evaluation of humanity's role in the cosmic narrative. This search also presents you with a serious ethical dilemma. Should we attempt contact with intelligent life, or would it be wiser to maintain our distance, considering that encounters between different civilizations on our own world have often ended disastrously? Conversely, the Fermi paradox confronts you with a stark question. Given the sheer number of stars and planets, why haven't we detected any definitive signs of intelligent life? Perhaps civilizations tend to annihilate themselves before they can reach out, or maybe they employ technologies you cannot yet recognize. This deep mystery only adds to the complexity of the search. In the meantime, projects like the Search for Extraterrestrial Intelligence, or SETI, continue to scan the cosmos for signals. And while listening to the cosmic silence can be daunting, each day moves you closer to an answer. Astrobiology, the scientific discipline dedicated to understanding the conditions necessary for life throughout the cosmos, is emerging as an indispensable instrument for discovery. Every new exoplanet identified and each investigation into Earth's most extreme environments offer vital clues that could guide us toward finding life on other worlds. Although the observable horizon imposes a physical limit on our sight, the human imagination faces no such constraints, prompting us to contemplate not just what is out there, but to ask who we are and who we aspire to become within this grand cosmic context. The sheer grandeur of the universe raises a host of compelling questions about its ultimate destiny and what the future holds for this intricate, ever-evolving cosmos. To even begin to grasp the fate of the universe, you must first turn your attention to the expansion that started billions of years ago with the Big Bang. That initial cosmic explosion was merely the opening chapter in a story that is still being written, leaving us with the central question of whether the universe will continue expanding forever. As galaxies perpetually recede from one another, the concept of an expanding cosmos becomes strikingly clear. Picture yourself in a room filled with balloons that all start inflating at once. From any point, you would see the other balloons moving away. In this analogy, every galaxy acts like one of those balloons. But this simple visual raises profound questions about the universe's future. Scientists have observed that this expansion is not only ongoing, but is actually accelerating, as if an unstoppable pump were continuously forcing more air into each balloon. What force could possibly be responsible for this acceleration? The answer appears to lie with two of the most enigmatic components of our universe: dark energy and dark matter. While we cannot perceive them directly, their influence is fundamental to the cosmos's structure and its accelerating expansion. You can think of dark energy as an invisible engine that is relentlessly pushing the universe outward at an ever-increasing velocity, shaping the destiny of everything within it. This accelerated expansion, however, brings forth a rather unsettling question. Will there come a point when distant galaxies are so far away that their light can no longer reach us? If this process continues unabated, our observable horizon may shrink over time, much like watching a movie that gradually becomes hopelessly blurry. One of the most debated scenarios for this future is the Big Rip, where the force of expansion eventually overpowers gravity itself, violently tearing apart galaxies, stars, and even atoms, leaving behind a cosmos of isolated particles adrift in overwhelming darkness. Yet, this is not the only potential fate that awaits. An alternative scenario is the Big Freeze, in which the universe expands infinitely but steadily cools until it becomes a dark and frigid expanse. In this future, stars would eventually exhaust their fuel and die out, transforming the cosmos into a silent, icy void where life as we know it could not possibly survive. Conversely, there is also the possibility of a big crunch, where expansion halts and reverses, causing the universe to collapse back in on itself like a deflating balloon, potentially leading to a new Big Bang and the start of a brand new cosmic cycle. Each of these potential outcomes compels you to reflect on your own place within the cosmos. If the universe is destined to grow cold and lifeless, what does that imply about the significance of our existence and our deepest aspirations? Contemplating our collective universal fate is an invitation to meditate on life, mortality, and the very purpose of being. Through its relentless pursuit of knowledge, science provides us with the tools to navigate these profound and complex ideas. From the earliest philosophers to contemporary astrophysicists, humanity has persistently sought to unlock the universe's secrets, and in exploring its future, we are inevitably exploring our own. The question remains whether we will be passive observers of this cosmic drama,
or if we can somehow influence our own destiny. On this incredible journey, our greatest allies are our innate curiosity and our unyielding drive to explore, pushing us to look deeper into the unknown. As our technology progresses, the instruments we use to study the cosmos grow increasingly sophisticated, with new telescopes and ambitious space missions enabling us to peer further into space than ever before imagined. Every breakthrough brings us a step closer to deciphering the true future of the universe, while theories like the multiverse, which posits the existence of other universes, add fascinating new layers to our inquiry. If countless other universes do exist, what futures might await them? The deep interconnection between the universe's story and our own is a truly captivating subject to consider. As you look toward the future, it is vital to recognize that each cosmic discovery not only enhances our understanding of the cosmos, but also reveals something profound about ourselves. Ultimately, the search for answers about the universe's destiny is a search for a deeper comprehension of our own existence and our place within it. As this reflection comes to a close, you might find yourself contemplating the vast horizon that lies before us. Every star that illuminates the night sky serves as a powerful reminder that while the future of the universe remains uncertain, our curiosity and determination to understand will continue to light our path forward. This epic journey of discovery has only just begun, and the greatest wonders still await us. Within this immense and enigmatic universe, we are confronted by a multitude of paradoxes and mysteries that continually challenge our grasp of reality. For instance, what happens to the fabric of space that exists beyond the edge of our observable horizon? This is a question that fascinates both scientists and philosophers. Our innate human curiosity compels us to explore and find answers, yet we frequently encounter scenarios that seem to defy all logic, pushing the very limits of our comprehension. A perfect illustration of this is the singularity, which resides at the core of black holes. How can any object become so incredibly dense that its gravity ensnares everything, including light itself? Picture a sphere in space so compacted that if you venture too close, escape becomes impossible. The boundary defining this sphere is known as the event horizon, a point that for any outside observer, like us, remains an absolute enigma, as anything crossing that line vanishes forever from our sight, making you question what secrets could be hidden inside. Moving into the realm of what we can observe, another fascinating puzzle emerges. How is it possible for the universe's expansion to propel some galaxies away from us faster than the speed of light? On the surface, this appears to defy the fundamental laws of physics we hold dear. However, it is the expansion of space itself that makes this phenomenon possible, presenting you with the paradox of light speed as a universal limit. While no object can travel through a vacuum faster than light, the stretching fabric of the universe can carry galaxies away at speeds that seem to exceed this cosmic constraint, forcing you to ask if our grasp of physics is incomplete. Another profound paradox is found in the concept of dark matter. Why is it that the universe seems to be constructed primarily from a substance that you cannot see or directly detect? This mysterious material does not emit or reflect any light, yet its gravitational force is a crucial influence on the formation and behavior of galaxies. The fact that something can be both so widespread and so completely elusive compels you to reconsider the very nature of matter and question how well we truly comprehend the building blocks of our universe. And then you have dark energy, that baffling force that is accelerating the expansion of the cosmos. What is its origin? And why does it appear to be a fundamental property of reality? As the universe continues to grow, this dark energy seems to be the determining factor in its ultimate destiny. Yet, much like dark matter, its true identity remains a complete puzzle, making you wonder if you are contending with a force that fundamentally challenges our ideas of gravity and space. When you look toward the future, another paradox presents itself, the notion of a potentially eternal universe. While certain models propose that the cosmos will eventually enter a repeating cycle of contraction and expansion, others suggest it will simply cool down and fade into nothingness. The question of whether the universe might lack an ultimate end forces you to contemplate your own existence and the significance of your place in this immeasurable expanse. Cosmology also confronts you with quandaries about time itself, questioning if it is the linear progression you perceive, or merely an illusion shaped by your consciousness. And the puzzles certainly don't stop there. You have the renowned Fermi paradox, which asks a simple yet profound question. If the universe is so ancient and vast, why have you not encountered any evidence of extraterrestrial intelligence? Perhaps advanced civilizations tend to annihilate themselves before they can establish contact. Or maybe other life forms exist that do not utilize technologies we would ever recognize. This conundrum adds yet another layer of complexity to the grand narrative of life in the cosmos, making you wonder if humanity is truly alone. As you begin to explore the theory of the multiverse, even more captivating questions come to the forefront. If an infinite number of universes do exist, each with its own distinct laws of physics, what would that imply about your own understanding of reality? It could mean that in some alternate dimension, the fundamental rules are completely different, and your own life is unfolding in ways you could never possibly conceive. The most significant paradox of all might be related to human knowledge itself. As you probe the observable horizon and beyond, it seems that every answer you find only unlocks a host of new questions. This leads to the humbling possibility that you may never achieve a complete understanding of the universe in its entirety. This uncertainty is simultaneously a great challenge and a source of liberation, inviting you to continue the endless journey of exploration, learning, and questioning. Ultimately, these profound questions serve to unite all of us, reminding you that despite our differences, we are connected by a shared wonder for the universe that envelops us. So, when confronted by these paradoxes, it's important to remember that the objective isn't just to find definitive answers, but to cherish the ongoing voyage of discovery. It is this fundamental curiosity that drives you to keep gazing at the stars, searching for truths you may never fully comprehend. The concept of infinity has captivated humanity since the dawn of time, but you have to ask what it genuinely means for something to be without limits. We often equate it with the notion of endless space, a feeling you get when looking up at the night sky and sensing its boundless depth. Yet, the observable horizon of our universe poses a fascinating question. Even in a cosmos that appears infinite, could there be a fundamental boundary to what you are capable of knowing? When you contemplate the observable horizon, it's nearly impossible not to wonder about what lies beyond it. Could there be other universes, hidden dimensions, or entirely different realities that you will never be able to perceive? This idea might seem overwhelming, but it is also a source of deep inspiration. The thought that something exists beyond your comprehension encourages you to reflect on the very nature of being and your own small role in the grand cosmic scheme. The philosophy of infinity is not confined to astronomy. It also touches on abstract concepts like time and possibility. For a moment, imagine that every single star you see in the sky represents a path in life you did not choose. This thought experiment makes you consider how many of those potential realities are forever lost within the sheer vastness of the universe. The very idea of infinity makes you consider how your decisions, while personally significant, are just tiny pieces of a much larger reality. A crucial element in this is the universe's expansion,
which paradoxically limits what you are able to see as it grows. This presents a genuine conceptual challenge. How can something so incredibly vast also be constrained? It leads you to wonder whether infinity itself follows a set of rules that are still far beyond your understanding.
Contemplating infinity inevitably draws you to re-examine the nature of time. If time stretches on endlessly, does that suggest that every event that has ever occurred is bound to happen again? This notion has been investigated across diverse cultures and philosophies, from the cyclical patterns of the seasons to beliefs about reincarnation. The relationship between endlessness and time confronts you with deep questions about your destiny and the legacy you will ultimately leave. The existence of an observable horizon implies that some things are simply beyond your capacity to know. What transpires on the other side of this boundary? Are those regions completely empty, or are they populated with life and civilizations you will never encounter? Entertaining the possibility of other conscious beings existing beyond your reach sparks a cascade of questions regarding the fundamental nature of life and awareness. Within this framework, the concept of the multiverse naturally comes to mind. If your own universe is but one of a countless many, what does that imply for your grasp of infinity? The proposition of other realities, each governed by different physical laws, fundamentally challenges your perception of what is possible. It leaves you to imagine a universe where everything is profoundly different, where time flows in an unfamiliar way, or where matter assumes forms you cannot even begin to conceive. The paradoxes that emerge from thinking about infinity are equally captivating. Can you ever truly comprehend a universe that has no end? Or are you destined to remain ignorant of what lies beyond your perceptual limits? This uncertainty can be unsettling, but it also serves as a tremendous source of inspiration. At its very core, the pursuit of knowledge is an expression of deep reverence for the unknown. The philosophy of infinity also pushes you to reflect on your own existence. In a universe of such immense scale, what does it truly mean to be conscious? Some philosophical traditions propose that your capacity for wonder and curiosity is what defines you as a human. Perhaps the search for meaning and your inherent connection to the infinite are the very forces that compel you to continue exploring and dreaming. As you contemplate the observable horizon, it is crucial to recognize that your perception is inherently framed by your own existence. The realization that there is more than you can ever see or comprehend should serve as a powerful reminder of your own humility in the grand cosmic scheme. You are, in the end, a very small part of a much larger whole. Yet this small part is profoundly worthy of both exploration and celebration. The link between the infinite and your daily life is also incredibly profound. How does your understanding of the cosmos actually shape your decisions and personal values? If the universe is truly endless, what is your particular role within it? Engaging with these questions can lead you to a renewed sense of purpose and a deeper connection to the entirety of existence. Ultimately, the philosophy of infinity is an invitation to embrace uncertainty. In an era where you are encouraged to seek concrete and final answers, it is vital to remember that some questions may never be resolved. The mere act of asking about infinity can unlock a world of possibilities, showing that the observable horizon doesn't just limit you. It encourages you to keep seeking, exploring, and imagining what lies beyond. Examining the observable horizon opens a window to the universe, while also raising profound questions about your place within it.
What does it genuinely mean to be a component of such a vast and mysterious cosmos? Reflecting on this boundary invites you to consider matters that extend beyond physics, prompting you to think about the very essence of your being. The observable horizon shows that, despite all you have managed to understand, there are absolute limits to what you can know. Yet, what is the effect of realizing that an immense universe lies just beyond your sight? This thought might seem daunting, but it is also deeply inspiring. It acts as a constant reminder that there is always more to find, confirming that human knowledge is a journey of perpetual expansion. The implications for humanity are astounding. If you picture the universe as a book, then the observable horizon is simply its cover, with chapters you have never read and stories yet to be told, hidden inside. Will you dare to explore these pages? The quest for knowledge about what is beyond your horizon is not just a scientific mission, but also an innate desire to understand your place in the cosmic narrative. The vastness of the universe also brings up questions about life itself. With so many galaxies and stars, could other forms of life exist? It's possible that advanced civilizations thrive in corners of the cosmos you've never explored. The chance that you are not alone in the universe evokes both excitement and apprehension, forcing you to question your identity and responsibilities in such an immense setting. Science fiction has explored these concepts for decades, envisioning encounters with beings from other worlds. For now, however, the reality is that you can only speculate. As you advance in your understanding of the universe, you must also reflect on the ethical and philosophical frameworks to apply in the search for life beyond your horizon. What would it mean for you if you discovered other sentient beings? How would such a revelation transform your perspective on humanity? The concept of the observable horizon presents you with a question of humility. In a universe that is constantly expanding, how can you be so presumptuous as to believe you are the center of everything? This reflection should serve as a call to action, inviting you to adopt a more collaborative approach and to work together as a species to understand not only your planet, but the cosmos as a whole. The quest to understand the observable horizon is a pursuit that unites all of us as a species, reminding you that we share a single home, a small planet adrift in an immense universe. This shared perspective brings with it a profound responsibility to care for and preserve our world for the future. When you gaze up at the star-filled sky, you are also compelled to look inward and ask what this cosmic reality means for your culture, your personal beliefs, and your very way of life. It becomes clear that science and spirituality can indeed work in tandem during this shared search for profound answers. A more complete understanding of the cosmos could very well introduce entirely new modes of thinking and forge a deeper connection to the world that surrounds you. At the same time, it opens the door to immense philosophical questions, such as what the existence of an infinite universe implies for your personal search for meaning and purpose. Exploring the observable horizon can set you on a path of self-discovery, where you confront these fundamental inquiries about your own existence. Are you simply a cosmic fluke, or is there a more significant reason for your being here? This journey becomes as much about understanding yourself as it is about understanding the universe. Humanity's future is inextricably woven into our capacity to explore and comprehend the cosmos around us. Science gives you the tools necessary to push your boundaries, but it is imagination and creativity that empower you to dream of what might lie beyond them, leaving you to wonder what discoveries and new theories await. As we embark on a new era of space exploration, it is vital to reflect on the ethical implications of our ventures. The hunt for life on other planets, the colonization of new worlds,
and the exploitation of cosmic resources are subjects that demand deep moral contemplation to ensure our actions are both responsible and sustainable. The observable horizon functions as a mirror, reflecting back our deepest hopes, our greatest fears, and our highest aspirations. It serves as a reminder that although you are small against the vastness of the cosmos, you are nevertheless a part of something far greater than yourself, and each discovery brings you closer to the truth. Our pursuit of knowledge about the cosmic boundary is not just a scientific question. It is a voyage to understand our place in the universe. As we persist in our exploration, we must recognize the importance of passing our discoveries and reflections on to the generations that will follow us. Ultimately, the legacy of humanity may not be measured by what we find, but by how we choose to conduct ourselves within this immense cosmos. Every individual, from the scientist making a breakthrough to the dreamer envisioning new possibilities, plays a part in this cosmic narrative. So, remember that every question you ask and every answer you find is a step toward a future of unity and boundless exploration. The very idea of the observable horizon is a captivating concept that invites you to contemplate your own place on the vast stage of the universe. As we conclude this journey, it's crucial to ask what you have genuinely learned about yourself and the cosmos that envelops you. This is not simply a matter of science. It is a journey to understand your own existence and what might lie beyond what you can see. As you probe the edges of the known universe, you start to see that the observable horizon is not merely a physical barrier, but a reflection of your own human limitations. You are confronted by intriguing questions, such as how far your search for answers can truly go. While science provides powerful tools, there will always be a corner of the universe that remains shrouded in mystery. What lies there? And could other forms of life be waiting in that profound darkness? Consider that 95% of the universe is composed of invisible dark matter and dark energy, a fact that fundamentally challenges your perception of reality. These complex but crucial concepts are foundational to unraveling the very fabric of the cosmos. The continuous expansion of the universe, initiated by the Big Bang, offers a potent analogy. Imagine a balloon being inflated, where each point on its surface steadily moves away from all others. This makes you ponder if the universe, too, might have an end, forcing you to reflect on your own temporality in this immense space. Every time you look at the night sky, you are seeing fragments of the past, as the light reaching your eyes has journeyed for billions of years to arrive here. This phenomenon shows that truth can be hidden in time itself, with the observable horizon marking the boundary where time and space intertwine. When you reflect on the cosmic microwave background radiation, the faint afterglow of the Big Bang, you encounter another compelling question. This whisper from the past connects you to the essence of creation, inviting you to wonder what secrets it might still hold about the universe's earliest moments. The concept of multidimensionality, which posits the existence of parallel universes, leads to a profound meditation on the nature of reality itself. If other universes exist, it raises questions about identity and destiny, suggesting your own experiences may be just one part of a vast mosaic of possibilities. The philosophy of infinity also plays a vital role in your comprehension of the observable horizon, making you question if the universe is truly endless, and if some things will forever lie beyond your understanding. It reminds you that the pursuit of knowledge is a journey without a final destination, where each discovery brings you closer to the truth while urging you to continue exploring the unknown. Here,
the fields of science and philosophy merge, compelling you to consider not only what is known, but also the vast expanse of what remains unknown. This journey serves as a powerful reminder that for all our progress, the universe's enigmas may far outnumber our current explanations. The prospect of life elsewhere in the cosmos raises another question that fuels an unquenchable curiosity. Since the observable horizon sets a firm limit on our perception, you have to wonder if other forms of life, perhaps even more advanced, thrive just beyond our view. This thought is not just exciting, it prompts you to think about the potential interconnectedness of all living things throughout the universe.
When you contemplate the future, the ultimate destiny of the universe inevitably comes to mind. Various theories about its end, whether through a final collapse or perpetual expansion, lead to a profound examination of our own place on this cosmic stage. It makes you question what kind of legacy humanity will leave behind in a cosmos that is constantly in flux.
The observable horizon also gives rise to paradoxes that force you to think in unconventional ways. How can a reality exist that is larger than anything you are capable of perceiving? This contradiction doesn't just put our scientific frameworks to the test. It invites you to delve into the very meaning of existence. With every technological leap in observation, you push back the horizon, only to encounter new and more distant limits. The question becomes whether these barriers can ever truly be overcome. Human curiosity, however, is insatiable, and as long as you persist in asking questions, you will continue to uncover answers and open new pathways into the unknown. In the end, the observable horizon is much more than a simple boundary. It represents an ongoing voyage toward greater understanding and exploration. It reminds you that while a great deal is still a mystery, every single discovery inches you closer to unraveling the fundamental secrets of the universe. The shared pursuit of knowledge is what unites us, challenging you to continue your exploration, to keep asking questions, and to stand in awe of the immensity that envelops us. So, as you look up at the star-filled sky, remember that every star is both a symbol of how far we've advanced and a promise of how much more is still waiting to be found.